Hi, class. This is 14.2, and the big idea of this section is that if we choose a good sample, then we will have a we'll have reasonable, reliable data. So that's the first blank in these notes here, is if we choose a good sample. Okay, and then it kind of explains, it goes deeper, what is a good sample? Well, a good sample is one that well represents the population and is large enough to cover the variability in the population. So, I mean, the differences within the individuals in the population. Okay, so here's an example of what like a bad sample would lead to. So from the previous section, we did this problem and I was showing you how if I just took a sample of the quarters, like the top like inch or so of the quarters here, you know, and I poured that out and I measured it and I counted how much was in there. And then in my example, I said, okay, well, that was 20. Then I could use that sample and say, well, that means the next inch here is probably also 20, and the last inch is probably also 20. So it helps me give that estimate of how much was in the full jar just by counting the top inch. Well, if the top inch is wrong, and like if we have something, it's a situation like we have in this example, with the coins, and let's just pretend they're all quarters too right here. But if I look at the top inch here of coins, notice how the jar kind of it's fat at the bottom and then it comes in on the side. See how like so let me use my pointer here. So see how it goes, it's fat on the bottom and then it goes in at this. So if I tried the same thing with this one, where I was like, okay, let me just measure the first inch of coins, it would be how much coins are in here. Well, that's a smaller diameter. There's going to be fewer coins in here than there is in this. I'm circling the next inch here. So if I count those and I find there's 15, and I say, okay, so therefore the next inch is also 15, and the next inch is also 15, then my whole estimate for how much is in the jar is going to be wrong, because my sample that I originally had chosen, the first inch here, is not like the other inches that below it in the jar, right? Okay, so that's it, that this sample was not representative of the other inches. So that's why it's not a good sample. But that's just an example. Another example is if, let's say that I'm trying to figure out approximately how many, or the proportion of Democrats at Fresno City College, students and faculty. If I'm trying to figure that out, would it be a good idea to, when I go looking for this good sample of mine, would it be a good idea for me to go and sample my friends? Let me just ask my friends, and however many of my friends are Democrats, then that's probably the same ratio as the entire school. Would that be a good choice? Would that be a representative sample? And hopefully what comes to mind is you're probably thinking, well, your friends are probably similar in mindset and values or whatever with you. So if you like have a certain political stance, whether you're Republican or Democrat or whatever, your friends are most likely that same, not necessarily, but most likely that same political party. So your friends would not be a good representative sample of the entire, Fresno City College faculty and students, right? So I'm hoping that you would see that would be a bias sample. They call it bias when it's more likely to pick up, maybe Republicans if I'm a Republican, or it's more likely to pick up Democrats because maybe if I was a Democrat, right? So I'm more, because of the sample that I chose, it makes it more likely, it changes the proportion of Democrats I'm going to get. So it's important that we pick a really good sample, and it's important the method that we use to go pick our sample, because our data, our final estimates that we're going to give anybody is all based on our sample and how good our sample is. So they just to point out, the first thing is it's representative of the population. And the second thing is that it's large enough to cover the variability in the population. So I do have some examples where they're comparing the sample size to the size of the population. So let me just go back here. And this is called the sampling proportion, or the rate. It's the ratio means fraction, of the number in the sample. So that's the numerator, the number in the sample, to the number in the population. And they want you to write this as a percent, and they call this a sampling proportion. So here's an example. A city has 8,345 registered voters. There is an election for mayor with 3 candidates: Smith, Jones, and Brown. The day before the election, a phone poll of 690 randomly chosen registered voters had these results. 179 people would vote for Smith, 69 said they'd vote for Jones, and 442 said they'd vote for Brown. Find the sampling proportion for the survey, round to the nearest 100. So the sampling proportion is the little n, which is the number in your sample, over the big N. The big N is usually the number in your population. So how many were in our sample? It says the day before the election, a phone poll, which is a sample of 690 randomly chosen voters, had these results. So there's 690 people that were being questioned. So that's the number of people in our sample, 690. Then of how many people in the total population, they said a city has 8,345 registered voters. So out of the 8,345. And so that is the that is the ratio there. And it's 0.83 or 0.08. Oh, and they just want us to be accurate to the hundredths place. So 0.08 is fine. All right. So then it says, give the sample statistic estimating the percentage of the vote going to Brown. So here we want to put the number going to Brown over the total and in the sample. So the number that voted for Brown was 442 over 690 were the total number sampled. This is also called This number is called the sample proportion. And they want us to write this in the nearest percent. So okay, so it's 64%. Then they say the actual election resulted in Brown receiving 60% of the votes. Find the sampling error as a percent. So then you just do 64 minus 60. And the difference between the actual and the actual and the predicted is 4%. So your sampling error is 4%. There we go. So let's go on to the next problem. So like I said, we want a good sample, but a biased sample is a sample that does not represent the population well. A biased sample is one in which there probably is, like I said, it's an example of if I use my friends to approximate as a sample to approximate the number of Democrats in the school. If I think, oh, look, 50% of my friends are Democrats, so therefore 50% of Fresno State College is Democrat. I don't think it's good because, like I said, my friends were probably more likely to have a certain political following because they're my friends, because they share similar values as me. So people with certain characteristics, especially the one we're interested in, are more likely or less likely to be in that group because it was of the way it was chosen. It was just, people I knew. So when that happens, when for whatever reason, one person and one type of person in the population is favored over other people, then that's called selection bias. And a very famous story of that was they tried to predict who was going to win the presidency, and they didn't realize that they were using a phone system people were going to phone in and say who they were going to vote for, and they were going to use that to kind of predict who was going to really win the election. Well, people in that day, only rich people had a home phone. So they were only getting the rich person's opinion, and so rich people were overrepresented in their sample, and poor people were underrepresented. And so it didn't, their prediction was actually very wrong. So, and it's because it suffered from selection bias, that it was selecting rich people to be in the sample who were voting differently that year on the president. So anyways, that's just another example of a sample bias. All right. So the next thing that you may be thinking is, well, if we don't want our sample to be biased, maybe we can make sure that there's the same amount of white people in our sample. There's the same amount as we have in total college. So maybe I'm trying to look for this really good sample. Maybe I would think, okay, well, I don't know what the percentage of white people really is at Fresno State College, but let's say it's 27%. Well, then 27% of the people that I'm going to be sampling should also be white. Maybe you think that. That's what, and then if there's 20% are Black or African American, then guess what? Then 20% of my sample should be Black or African American, right? So that's called quota sampling. So we see certain characteristics in the entire population and we try to match it in the sample. And it sounds like a good idea, But the bad thing is that it doesn't really work. And that's because it's very, very hard to imitate every subgroup. At first you could go by race. Okay, like we have to make sure, all the races are represented correctly, but what about the income levels? Okay, then we have to make sure the income levels are all the same, whatever the percentage of people in this, income level has to be the same in my sample, and so like we can go on for, and then the same number of people living in rural areas has to be the same as my sample. And then the number of pregnant teen moms has to be the same in my sample as it is on the college. And we could go on forever with different, like subgroups of people that we want to match our sample to. And the problem is that we are not going to cover all of them. And because we're not going to end up covering all of them, we're going to be leaving out some of them. And then we're going to be biasing our sample because there's certain people in that they're going to be more likely to be in a sample because we thought about their subgroup, and then other people that are not going to get in, because we just didn't think of, maybe they just wasn't a popular topic at this time, so quota sampling does not work very well, but it is a type of sampling that we attempt to get a good sample with. Anyways, then there's convenience sampling. And so what I mentioned already is like, if you're just like, I'm going to sample people that are convenient for me to talk to. And that's like an example of that is me just doing a sample, and you think it's you doing a questionnaire or sample on my friends. That was just convenient because they're around me, and because of that, they're probably going to all share some kind of common characteristics. For example, if I stand in front of Walmart and get, ask for people public opinion instead of in front of Walmart, guess what? Well, that's a certain economic, that's usually, like that I'm going to be attracting more of because I'm in front of Walmart and I'm not in front of Macy's or whatever. So convenience sampling by nature automatically, you're going to draw people in, you're going to attract a certain type of person to the sample, to be in your sample, when you want everybody to be equally represented in your sample. And so convenience sampling is often not reliable. And then what they've found through like just experience is researchers now have accepted simple random sampling as the best way to get a good representative sample. And a simple random sample means, well, this is the most basic way to think about it, is if I put everybody in, and this is kind of not logistically easy, but if I put all 15,000 names in a hat, all the kids that were in Fresno City College, and I shook it up and made sure it was really like, and I drew those names out of a hat, and those were who going to be in my sample, that is the best way to get a good representative sample, because automatically, but randomly, I'm going to get the right amount of ratio of all the subgroups that are out there. And if I take a large enough sample, but it's not exactly perfect either because it is random. So it is a sample. It's not the entire population. And we may randomly get a little bit more of one subgroup than another in that particular sample. So if it's large enough, we probably won't. It'll probably be good. So it depends on, like we said earlier, it depends on the amount of variability you have in the population. If you have lots of different, ethnicities and whatever, then you probably want to have a bigger sample to make sure that the bigger your sample is, the more likely all those subgroups are going to be the same. They're going to have the same representative, or the correct representation. Anyways, simple random sampling, like I said, putting all those 15,000 names in a hat, is extremely hard to do because it's not very logistically friendly. Like if I was just gonna pick 15,000 people, like I would have to chase down these 15,000 or not 15,000, but like however many, like 1,500 or however many I chose to sample. And that's a lot of running down and calling people and getting, it would be so much easier if I just picked like 5 random classrooms around the college and then just sampled everybody in the classroom because I know they meet, I know where they're going to meet, I know I could just go show up one spot, get 35 people in one spot at one time, and that is more logistically friendly. So that's called cluster sampling, and it's what we kind of mentioned in chapter 6 was we want to be accurate, but at the same time, we only have so much time and so much effort and so much money to like put toward these projects. So we're going to settle for like the second best. It would be like cluster sampling. And that's where you pick randomly, and that's number 6 here. I'm skipping to number 6, but you randomly select a group, a heterogeneous group. So a group that you believe is differently, it has a good different set of values or whatever in the group. And you randomly select groups of people. So that's like you randomly select classrooms. And then you sample everybody in each group. And that makes it the logistics of sampling much easier, but you're still using random chance because you are randomly picking the class itself. And if it's reasonable for you to believe that, unless it's like a pro-Democrat class, that's the name of the class, like if it's reasonable for you to believe that like in this math class, the proportion of Democrats is probably about the same as in this science class or whatever, then that would be okay, to use this method, They also call this area sampling. And another sampling, it's like an acceptable way to sample that uses the random sample idea is stratified sampling. And that's if you break, you're still dividing up the population into groups. And so maybe think of like the states. So maybe if I'm trying to find information about the American general public, maybe I might break the country into region by states. And then I would randomly pick states that are gonna get chosen to, so maybe then I'd randomly pick 10 states that are gonna get sampled. And then a lot of times that's called a stratified sample. And then you would do simple random sampling inside that state. And a lot of times stratified sampling is like, it's like, and stratified sampling, usually and here's an even better example of stratified sampling. Let's say that the president wants to go out to lunch and he wants, maybe he has this decision to make, and he wants the views of Republicans, independents, and of Democrats. So what he would do is he would divide up, the people he was thinking about going to lunch with, into those 3 groups: Democrats, Republicans, and independents. And then he would randomly pick maybe 3 people from each of those 3 groups to have lunch with him, so that because he's seen that the Republicans are all kind of similar in mind and similar thinking, at least that's what he thinks, he's assuming. And the same thing with like Democrats and independents. So it's sort of kind of like quota sampling in a way, because you separate people into similar groups, and then you do a simple random sample from each of those similar groups. We call homogeneous groups of people. And stratified sampling is usually several layers. So maybe after they randomly pick 10 states that are going to do the sample. Then within those states, then they randomly pick, 7 counties from each state of those those chosen states. And then from each county, they'll randomly pick 6 neighborhoods or whatever, and then like from the neighborhoods, they'll pick 7 streets, and then those will be the 7. And then they'll randomly pick 7 people on a certain block to be part of their, sample. So that's one way of kind of making sure that we kind of get a good variety of different people from like over the country, different parts of the country and whatnot. So stratified sampling, I feel like it's kind of like quota, but sampling, but they mixed in the random sample, the random sampling into it as well. So anyways, one big difference between stratified sampling and cluster sampling, they both are dividing the country into groups, but cluster sampling, the groups they're dividing into are differently minded people. Each of the groups are very representative of the entire population. And then they randomly select the actual group, but then when they find the group, they sample everyone in the group. While satisfied sampling, they randomly pick, well, they divide the country into by states or whatever, and then they randomly pick sample inside the strata. So all right, and usually stratified sampling, I mean, they want to get a little bit of somebody's opinion from all the states, so then, but they're trying to get, like a variety of different people. And that's what it's kind of the idea of stratified sampling. All right. Here, let's go over these examples. For each scenario below, determine the sampling method used to obtain a sample. An auditor selects 200 student applications in category 1, 100 applications in category 2, and 100 student applications in category 3. And it's definitely like they broke them into groups and they're picking from each of the groups. So this one sounds to me like quota sampling, and they don't talk about any randomness in this at all. It was, if this was stratified sampling, then they would have randomly chosen 100 students from category 1. But they don't. They just select the students from category 1 or category 2. So this one, A, is quota sampling. The first 60 people entering a zoo are asked if they support an increase in taxes to support zoo expansion. So they're just sitting there waiting for these people to come to them. So this is convenience sampling. And they didn't make any effort to like make sure that a certain group here was covered, or they didn't make sure to do any of that. So just convenience. An auditor first separates the students' applications by school: agriculture, arts, humanities, engineering, nursing, and mathematics. 3 of these schools are selected at random and further divided by major. Then 10 majors are randomly selected within each school, and then 20 students are randomly selected from each of the selected majors. So this is stratified sampling. And they often like divide it up and then divide it up further and keep dividing it up with the idea that they're trying to get a little bit from each, from different areas, but and this is like several, several layers of strata. Strata are the groups that you broke it into, you divided it into. So, and that's often what you see with stratified sampling is several layers. So the fact that they broke it up by major, and then they broke it up they broke it up by like the school, then by the major, then by, it's like they broke it up again and again. It kept splitting up the population. And so that's stratified. C is stratified sampling. It's in the R. I'm adding it. All right, the next one is every 20th smartwatch coming off an assembly line is checked for defects. And this is one that I did not mention yet, but this is number 5, the systematic sampling. Systematic is if you take every 20th smartwatch, but you don't check every single one. You check but you don't want to check like the first 20, because what if those are fine, but then there was some kind of glitch in the machines that were making them after that one, right? So they do every 20th, and that seems really good for checking out the quality of items. So this is called systematic sampling. And all 3 of these, stratified, systematic, and cluster, are acceptable, and simple random, are acceptable sampling methods. It's like simple random would be the best, but like I said, it's often not logistically possible. Okay, then the last one here is a $50 gift card is given away at the regional teachers convention. Tickets are placed in a bin and the tickets are mixed up. The winning ticket is selected by the blindfolded person. So they put everybody's names in, then they mix it up. Everybody has an equal chance of getting chosen for this gift certificate. So this is simple random sampling. All right, then they said children in a large city are classified based on their neighborhood school they attend. A random sample of 4 schools is selected, and all the children from each of the selected schools are included in the sample. This is cluster sampling. All right, here's some bias that you do need to watch out for when you're doing sampling. And the first one is a self-selection bias. And this happens a lot in actually a lot of the surveys that you may, and polls that you may be exposed to a lot in real life. Like, I don't know how you feel, or I'm sure that you've seen this happen before, but like you go to McDonald's or you'll go to a restaurant and they'll say, hey, can you fill out the short survey for us? And let us know how we did on our business. They are asking, and because we are choosing to either be part of that sample and giving them information, or we're choosing not to be a part, that's called self-selection. If people are able to choose whether they want to be in your sample or not, that's not a good thing usually. The reason why is because people who very strongly feel one way or the other, they may just either choose not to be in your sample and not to cooperate at all. Like if it's maybe if there's a controversial subject that you're trying to get people's opinion on, and people that are just extremely not for it, they don't even want to talk to you. They think you're pro that thing or whatever. And so they don't even like choose to be a part of your sample. Then what's going to happen is you're going to get a lot of people, the only people that did respond to you and did choose to be part of your sample are are like of a certain mindset, and so it's going to be biased to certain people, the certain people who wanted to be part of your sample, and they probably wanted to be part of your sample because they had some type of characteristic in there, and your sample is not going to represent the true feelings of kind of the wider population. Okay, so that's self-selection. And like people are like, well, Ms. Schwanz, why do they use that then? Like, why do they do it when they know the results aren't going to be that accurate? And the answer to that question is like they are, like we said, like some of these sampling methods are not perfect. They have flaws, but they're better than nothing, kind of, like they're logistically so much easier than the perfect way of doing it. So like we just settle for it, like, and that's how I think a lot of these businesses feel. They're just like, well, I'd rather have, some response, from somebody, even if it's not so accurate, at least we have something, so that's why I think they still do it. But they know themselves that the responses they get back may not truly reflect the entire population that they're interested in. So they know that. They know to look at their results through, with what does that mean? Like, to like just second guess their results. And then you have a non-response bias. And it's kind of like exactly what I was talking about, but this one is when people decide not to respond. So like maybe you send out by mail or text message a survey for them to complete, and they don't. Let's say you send out 100 surveys and only 50 people respond and actually complete the survey. Well, you should really not trust those results, because there's so many people that didn't respond that you're just not getting a wide enough, you're not getting everybody's opinion, like if you're not getting a wide enough sample to get everybody's opinion. And most likely, like I said, if people are probably not responding because they either feel really strongly one way or the other about your opinion, your sample, or maybe they just don't care about that issue. So that, I mean, either way, like you're not hearing from quite a lot of people, and it's going to cause your results to be inaccurate. So there's selection bias. You should not allow people to choose whether they want to be in your sample or not. And there's non-response bias. And unfortunately, like you can give people cookies for being part of the sample, or you can try to really encourage them, but sometimes there's nothing we can do about these two things. Except for watch, what we call the response rate. So if like I said, if you send out 100 surveys and 95 and you get 95 returned, then that's a good response rate. And so you want your response rate to be high, and you also want ideally you don't want, I mean, the thing is, like, I feel like even with self-selection bias, you want to make that so available for people to choose whether they want to be in it or not. You want to choose your people, and then you have to make sure that they choose not to be in it. Or I don't know, I don't know. But I feel like these are, you just try to make these not happen as much as you can. But anyways, okay, moving on. This is, so let's see this example number 2. The Clinsburg Planning Department is trying to determine what percent of the people in the city want to spend public funds to revitalize the downtown mall. To do so, the department decides to conduct a survey. 5 professional interviewers are hired. Each interviewer is asked to pick a street corner within the city limits. And every day from 4 p.m. to 6 p.m., the interviewers are supposed to ask each passerby if he or she wishes to respond to a survey sponsored by Clinsburg City Hall. If the response is yes, the follow-up questions are asked. Are you in favor of spending public funds to revitalize the downtown mall? The interviewers are asked to return to the same street corner as many days as are necessary until each has conducted a total of 100 interviews. Here are the results of the survey. So they say, first, describe the target market. That is the population we are trying to draw a conclusion about, or we're talking about. Says the Clinsburg Planning Department is trying to determine what percent of the people in the city want to spend public funds to revitalize the downtown. So their target market is the people in the city. They're interested in the opinion of the people in the city. It says describe the sampling frame. Now, the sampling frame is the actual group of people that you are actually taking a sample from. So like I said earlier, there was that one example where like they were trying to get information from all Americans about how they're going to vote on this election, but they actually only got people who owned telephones. So their frame was a lot smaller than the actual population. There was a lot of people they were leaving out, that they were not getting surveys. They were not getting in the sample. So describe the sampling frame. Okay, so the sampling frame are people that are out on the street between 4 p.m. and 6 p.m. Do you think that that includes everyone in the city? I don't think so, because there's probably people that work on a daily basis from 4 to 6 p.m., right? So there's people being left that are automatically never going to get a chance to be in this, to voice their opinion here. So that's not good. Ideally, our frame would be the exact same thing as our target population. And everyone in our target population should have an equal chance to be in our sample. But it doesn't look like it's happening in this situation. I'm just thinking they're gonna meet a lot of unemployed people, like they're gonna be sampling more than employed people, because I'm just saying they're the ones that are not, out of work somewhere. So people on the street between 4 and 6. And it says describe the sample. So they got 5 different people to do this one sample. So it looks like if we add, like whether you want to add across or you want to add all the columns together, we can figure out how many people they actually spoke to. So actually, the people in this sample are actually the only ones that they're the ones that said yes and no. So you could add. So I wouldn't add the non-respondents. We're not going to we're not going to say that they were part of the sample. We're just going to add the 35 plus 65 plus 21 plus 79 plus 58 plus 42 plus 78 plus 22. Oh, and actually, we already know that these people were supposed to, and I'm looking at these numbers and I'm realizing they all add to 100 because each of these interviewers were supposed to do 100 people. So actually, I know that there's 5 people, they each did 100. So there's 500 people in the sample. But okay. I'm just making sure they all do add. This one, E, I don't think it does add to 100. They should have expected until they got 100. No, E does not add to 500. So maybe he just dropped the ball. Or maybe someone else picked up for him. But I think all the rest of them do, and I don't know if that's a mistake, but we could quickly just add up all the people that said yes, plus all the people that said no, and then we would find out all the people who were sampled. That's the way we would do that. So let me take a minute and do that. Okay, so, oh, and here's some things to describe the sample. I added up everyone in the yes column and I got 204. So 204 people responded yes to this survey. And then when I say survey, it means like questionnaire that people answer questions in the section. Okay. And then I added up everybody that said no, and then that was 271. And then so we are just describing a sample that 204 people responded yes and 271 said no. And the sample size was, I added up everyone who responded either yes or no. So I pretty much added up the 204 plus the 271, and I got this 475. That was our sample size. And then they asked, what is the sampling proportion if there are 5,000 citizens of Clinsburg? So the sampling proportion from the beginning of the lecture was the sample size over the total population of citizens. So the sample size was 475 over the total population was 5,000. So our sampling proportion is 0.095. So that's, if I move the decimals twice, that's 9.5%. So that's, we approximately sampled around 10% of the population, which is that's a good sampling proportion. Okay, then they asked, give the sample statistics for the percent of citizens who want to use public funds to revitalize downtown. So the ones who want to revitalize downtown were the ones who said yes. Now, let me just double check. Are you in favor of spending public funds to revitalize downtown? So an answer of yes here means they do want to revitalize downtown. And that was a total of 204 over the total number of people sampled, which is 475. So 204 out of 475 people wanted to use public funds to revise their downtown. So let's see what it is. So let's see, 204 divided by 475, and then that is 0.429. So I move the decimal twice, 42, 42.9% of people were for revitalizing downtown. So it sounds like under, the under half, half of the 50%, right? So what is the response rate? So what I did here to calculate the response rate, I took the number of people that actually responded by saying yes or no in the numerator, that was the 475, over, and then what I did is I added all the people together who are non-respondents plus the 475. So I added this column plus the 475. So there's people who did respond and the people who did not respond. I made that the total number here. So I did the people who did respond out of the total number of people who were asked to respond, and we get this response rate of 27%. So there we go. I hope that you found this video helpful, and we'll go over really exciting information in 14.3 next. Have a great day. Bye.